ESO's HARPS instrument in 2010, discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star. ESO's Very Large Telescope was used to detect carbon monoxide molecules in a remote galaxy, seen as it was 11 billion years ago, a feat that had remained elusive for 25 years. This allowed astronomers to obtain the most precise measurement of the cosmic temperature at such a remote epoch, and it matched the temperature predicted by the Big Bang Theory. The atmosphere around a super-Earth exoplanet was analysed for the first time using the VLT. The planet, which is known as GJ1214b, was studied as it passed in front of its parent star, and some of the starlight filtered through the planet's atmosphere. The atmosphere was found to be either mostly water in the form of steam, or dominated by thick clouds or haze. Using ESO's VLT, astronomers measured the age of the oldest star known in the Milky Way. At 13.2 billion years old, the star was born in the earliest era of star formation in the universe. Uranium was also detected in a Milky Way star and used as an independent estimate of the age of the galaxy. The VLT obtained the first ever image of a planet outside our solar system. The planet, which has a mass about 5 times that of Jupiter, orbits a failed star, a brown dwarf, at a distance of 55 times the average distance between the Earth and the Sun. In 2014, ALMA, the Atacama Large Millimeter Submillimeter Array, revealed remarkable details of a solar system that is forming. The images of HL Tauri were the sharpest ever made at sub-millimeter wavelengths. They show how forming planets are vacuuming up dust and gas in a protoplanetary disk. One of ESO's proudest moments came when 2 independent research teams, including ESO staff, arrived at a truly revolutionary finding: that the cosmos is not only expanding, but that it is doing so at an increasing rate. The findings of the separate teams were based on observations of exploding stars, or supernovae, including measurements made from ESO's telescopes at La Silla and Paranal. This discovery was rewarded with the 2011 Nobel Prize in Physics. And finally, several of ESO's flagship telescopes were used in a 20-year study to obtain the most detailed view ever of the surroundings of the monster lurking at the heart of our galaxy, a supermassive black hole. Astronomy is always moving forwards, and ESO's top 10 scientific discoveries are not set in stone. As long as astronomers continue to study the universe at ESO's observatories, unexpected and illuminating discoveries will follow. Who knows what exciting discoveries await and will find their way onto this list in the future. The results of the Pale Red Dot campaign, the quest to find a planet orbiting the closest star to the solar system, have now been announced. Astronomers have found clear evidence of a planet orbiting the star Proxima Centauri. This alien world is the closest possible abode for life outside the solar system. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. The search for other worlds has captivated imaginations throughout history. But only recently have we had the instruments able to detect worlds outside the solar system. These extrasolar planets, or exoplanets, went undetected until 25 years ago. Today, thanks to advances in telescope technology, astronomers have detected over 3,000. And now the scientists behind the Pale Red campaign have made a milestone discovery. They have discovered clear evidence for a potentially habitable planet orbiting Proxima Centauri, the closest star to the solar system. Using the HARP spectrograph on ESO's 3.6-meter telescope at La Silla in Chile, astronomers spent the first half of 2016 looking for the tiny back-and-forth wobble of the star caused by the gravitational pull of an orbiting planet. They were trying to build on 16 years of earlier observations that hinted of the presence of a planet but were inconclusive. Combining the data with observations from a network of telescopes around the world, the researchers confirmed the detection of an alien world. It's at least 1.3 times as massive as the Earth and orbits Proxima Centauri every 11.2 days. It was no easy task to identify the planet, however. Red dwarfs like Proxima Centauri are active stars prone to flares and can vary in ways that would mimic the presence of a planet. To exclude this possibility, the team carefully monitored the brightness of the star with a network of telescopes to ensure they didn't misidentify such an important discovery. Perhaps the most exciting aspect of this research is that the exoplanet called Proxima b orbits within the habitable zone of its star. This means that liquid water could exist on the planet's surface. If it were much closer, the heat from the star would boil the water away. And if it were further out, the planet's water would freeze solid. Since liquid water is essential for life as we know it, this makes Proxima b the closest exoplanet to Earth that may harbour life. However, the same stellar activity that made Proxima b so difficult to spot could also make it an inhospitable abode for life. The planet is bathed by intense ultraviolet and X-ray radiation. The planet also orbits Proxima Centauri extremely closely, only 5% of the Earth-Sun distance. It is still a matter of debate whether a planet so close to its star could support life. Proxima B's closeness to the Earth makes it an intriguing target in the search for X-life. Astronomers will use the next generation of telescopes, such as ESO's European Extremely Large Telescope, to make an intensive study of this fascinating alien world, in the hope of finding evidence of life elsewhere in the universe. And if interstellar probes become a Proxima B may be their first destination. Scientific knowledge of exoplanets has grown hugely in the last 25 years. With this discovery, and armed with ESO's next-generation telescope, we may soon be within reach of answering the age-old question: are we alone? This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. Survey telescopes are designed to scan large areas of the sky quickly and deeply, looking for the rarest and most interesting astronomical objects. They use the latest technology on their scouting missions and produce huge amounts of data. ESO's 2 dedicated survey telescopes are at work every clear night, carefully mapping the southern skies piece by piece. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. VISTA and the VST, 2 powerful survey telescopes. VISTA, the Visible and Infrared Survey Telescope for Astronomy, and the VST, the VLT Survey Telescope. Both telescopes are located at ESO's Paranal Observatory in Chile, and they are arguably the most powerful dedicated imaging survey telescopes in the world. Survey telescopes look for needles in haystacks, rare astronomical objects, such as potentially dangerous near-Earth asteroids, hidden clusters, exploding stars, and remote quasars. Unlike larger telescopes, which concentrate on tiny parts of the sky in extreme detail, VISTA and the VST study broad areas of the sky. The resulting surveys produce huge archives of scientific data and pick up many interesting objects. These can then be studied in greater detail by much larger telescopes, such as the neighbouring VLT. VISTA has a main mirror 4.1 meters across, making it by far the largest telescope in the world dedicated to surveying the sky at near-infrared wavelengths. Moreover, it is equipped with a state-of-the-art 67-megapixel camera, with the widest coverage of any astronomical near-infrared camera. VISTA began operations in 2010, and it can observe the sky with a sensitivity that is 40 times greater than that achieved with earlier survey telescopes. By observing in infrared light, VISTA can study objects that may be impossible to see in visible light because they are cool, obscured by dust clouds, or because their light has been stretched or redshifted away from the visible spectrum. The VST is a state-of-the-art 2.6-metre telescope equipped with a monster 268-megapixel CCD camera with a field of view 4 times the area of the full moon. The VST surveys the visible light night sky and complements VISTA's near-infrared sight. VISTA and the VST produce immense quantities of survey data and hugely increase the scientific discovery potential of the Paranal Observatory. The data is stored in vast archives of images and catalogues of objects that can be picked over by astronomers for decades to come. The survey telescopes will play a vital role in preparing the way for future facilities. Some of their discoveries will be targets for much more detailed study using the future European Extremely Large Telescope. ESO's survey telescopes will continue to map the sky in the finest detail. What they find will help to tackle some of the most exciting problems in astrophysics today, including the structure of the Milky Way and the nature of the mysterious dark matter and dark energy. This is the ESOcast, cutting-edge science and life behind the scenes at ESO, the European Southern Observatory. ESO operates 3 world-class observatories in Chile. Astronomers use these telescopes to study objects both close to home in the solar system and all the way out to the furthest reaches of the known universe. Observations with ESO telescopes have led to many breakthroughs in astronomy and, over the years, have been responsible for some truly remarkable findings. Here is our list of ESO's top 10 astronomical discoveries so far. Astronomers using ESO's Very Large Telescope have discovered by far the brightest galaxy yet found in the early universe, and found strong evidence that examples of the first generation of stars lurk within it, stars that were previously only theoretical. These massive, brilliant objects were the creators of the first heavy elements in elements that are necessary to forge the stars we see around us today, the planets that orbit them, and life as we know it. ESO telescopes have provided definitive proof that long gamma-ray bursts are linked with the climatic explosions of massive stars, therefore solving an enduring mystery. A telescope at Lucia was also able to observe the visible light from a short gamma-ray burst for the first time, showing that this family of objects most likely originates from colliding neutron stars. Astronomers using ESO's HARPS instrument in 2010 discovered a planetary system containing at least 5 planets orbiting the Sun-like star HD 10180. They also found evidence that 2 other planets may be present, one of which, if confirmed, would be among the lowest mass exoplanets ever found. Newer observations and reanalysis of the data suggest that there could be even more planets around this star.